So today we're going to start Chapter 5, Section 2, and today we're going to start learning about logarithmic functions and their graphs. Now we won't graph the logarithmic functions until the end of the notes. So today what we're going to do is learn how to switch between a log function or log form and exponential form. Now, logs and exponential functions are actually inverse functions. So back when I taught this, maybe 10 years ago, I was trying to find a way to help students remember how to convert. And I looked online and I couldn't find a way that made sense. A lot of things, if you Google, it'll say do a semicircle or keep the base the same and switch the exponent in the answer. So instead, what I decided to do is come up with an acronym to help students remember how to convert from exponential to log or from log to exponential. So when you have something that is in exponential form, it's in this setup of BEA. So the base, the exponent, and then it equals the answer. When it's in log form, so it's spelling B. So for example, if you had, let's say 4 squared, 4 is the base, 2 is the exponent, and the answer to this would be 16. When we go to convert into the log form, the log, I'm going to spell bay. So the bay, if you ever heard of somebody people would say opposites attract. So the opposite attraction to the log function is the exponential. So the bay of the exponential is the log. So what we would do is we would take the base, which would be 4 here, the answer, which is 16, and then put in the exponent. Now, the bases of the exponential and the base of the log function are always the same. You could also think of keeping the base the same, and then these two guys just switch places. Whatever's going to help you to remember. Because what we're going to be doing is, since we're not using a calculator, if you're given a problem in exponential form and you can't solve it, then you'll convert it to log. Or if it's given to you in log form and you can't solve it, then you're going to convert it to exponential. So this is my little trick of helping you to remember what goes where when you switch from one form to the other. So when you're doing the homework tonight, what you're going to be doing at the beginning of the homework is just switching from one form to the other. Then later on, you're going to be solving and then plugging in a value for x and then actually solving for the exponential. Now, if you remember from 5.1, when you graph the exponential function, remember it was always going through this order pair here of 0, 1, and the graph of the exponential looked like this. So the exponential function graph generally took on this shape. And because it's an inverse to the log is going to be like a reflection. So if it was reflecting across this line of y equals x, then the log function graph is going to look like going here through the order pair. So this was 0, 1. And now if you reverse it, this is 1, 0. And the log function is going to look like this. So it's like it's symmetrical. It's like a mirrored image. So on this side, this is the log form, and this is the exponential form. And we're going to practice converting. Let's try some examples on the next slide. So here, again, if you want to do the Bay trick, you can. So notice the instructions, convert from log to exponential or vice versa. So this problem is given to us in log form. So if you want to use my Bay trick, what you would recognize is this is the base, this is the answer, this is the exponent. So 2 to the third power equals 8. Now, what's nice about when you switch it from log to exponential, you could actually check your answer. If 2 to the third power doesn't equal 8, then you've done something wrong. Okay? Now, again, you can also just remember that the bases of the exponential and the base of the log are always going to be the same. And then here you could have just switched these spots. Either way. So remember, when you convert it into exponential, it's going to have base, exponent, and then answer. So in exponential, it spells B-E-A, like a person's name, Beatrice. And when it's in log, it's Bay. So let's try another one. So again, base, answer, exponent. So the base is 1/2, raised to the 1/4 power, negative 4 power equals 16. So if you think about it, we could actually test this out logically. And whenever you have a negative exponent, think reciprocal. So you could flip the 1/2 to 2/1, make the power positive, and then this just becomes 2 to the 4th, which is 16. So again, when you go from log to exponential, again, you could actually evaluate that exponential form and see if the two sides are equal. Let's try the next one. So again, BAE here, base, answer, exponent, 10 to the 5th power equals 100,000. So when it asks you to just switch forms, that's all you're doing is rearranging it. Now we're going to go from exponential to log. So remember, the 5 is the base, the 2 is the exponent, and the 25 is the answer. So when we go to fill it in, we're going to be putting it into BAE. So this would become log base 5 of 25 equals 2. Try the next one. It's in exponential form. So remember, this is the base, the negative 4 is the exponent, and the 1/81 is the answer. So log base 3, 1/81 equals -4. Now, one thing to keep in mind, that whenever you're evaluating these logs, the base and the number that you're taking the log of, these two numbers cannot be negative. However, the answer to the log, the answer can be negative. So just a little visual to help you remember some things. Now, if you remember, anything to the 0 power equals 1. But again, we'll go ahead and change this. So this becomes log. The base is the 3/4. 3/4 of 1 equals 0. So whenever you see a 1 right here, this answer is always going to be 0. And we're going to see a property coming up on the next slide. This is just converting from one form to the other. The beginning part of the homework is just this, converting it from one form to the other. Now let's look at some properties on the next slide. The next slide has some properties of logs. So the first one, again, the first one is the log form. So a log of base A of 1 is equal to 0, because you know that anything to the 0 power equals 1. So for example, let's say we had a problem like this. Now in the homework, you might get something like this where it's going to say, so this is applying property 1. If they give you something like this, find the value, and if they say 3, and they don't give you a variable, if it helps you to put in an X here or a y, you could put in a number. And then if we turn this to exponential, because again, remember, this would be b, a, e. So 3 to the y power equals 1. And here you need to recognize that when the answer is 1, this variable is always going to be a 0. So 3 to the 0 equals 1. So be able to recognize this property that anything to the 0 power equals 1. So if I use their example here, also, if you have log base A of 1, and if you put equal x, and then here, a to the x power equals 1, you should be able to recognize that x equals 0. So whenever the answer in the exponential equation or form is 1, that power is a 0. The next property, here they're giving us that for property number 2, they have log base A of A equals 1. And the reason why we know this, again, if I convert it to the exponential form, A to the first power, and this has a little subscript here. This should have actually been the power up there. And then equals A. So one thing to remember, that this, whenever this base is the same as the number you're trying to find the log of, when these are the same numbers, the answer is always equal to 1. So if I put in some numbers here, let's say I did log base 3 of 3, and I put equals x, and I was trying to find the value of x, or if they say evaluate this. So in the homework, they might not put equals x. If it helps you to add the equals x so you can do the Bay trick, you can do that. So then this would become 3 to the x power, and you would have to figure out 3 to what power equals 3, and you can see that that would be 3 to the first power. So that is the second property. Then the third one, now this one's missing something here. It's missing the exponential form here. So again, if this is the base answer exponent, then what we need to write here is a to the x power equals, and this whole thing is the answer, equals a to the x. So what we're doing here on the third property, fill that other little piece in. For the third property, so log a to the x equals x. Again, b, a, e. The base is the a. The exponent is over here, it's the x. And it equals this whole answer, a to the x. So let me do some with a number. So let's say it was log base 3, 3 to the 4th, and it says to evaluate. So if you want to add in an x here, what this becomes is this base, so the 3, raised to this exponent, put an x here, equals the answer. And then if you notice, this is back in 5-1, our one-to-one property. And notice the 3's would cancel and x equals 4. Now, another way that you can look at this exponential here, also another thing to remember is if you have an exponential equation with a log as the exponent, so let's say it's log base A of x equals x. Whenever these two bases, the base of the exponent and the base of the log are the same, what ends up happening here is this would cancel out and you're left with x equals 1. So shortcut, whenever the base of the log and the base of the exponent of what you're finding is the same, you could go right here to the answer. So little tricks here that we're going to see. And then one more property. So on number 4, if the log of base a of x is equal to the log of base a of y, then x equals y. So for example, for number 4, log base a of x equals log base a of y. Notice what will happen here are these cancel, just like it's like a base, and then x equals y. So let's do one with some numbers. So let's say it's log base 3 of x equals log base 3 of 4. And notice what we can do here is the log base 3's cancel, and you're left with x equals 4. Oh, you know what I did? All right, next one. So here we go. It wants us to solve for x. So the bottom line is if you're given something like this and they ask you to evaluate it without a calculator, if you can't do it when it's in log form, then you're going to switch it to exponential. So we're going to go ahead and change this, and we could use our Bay trick if you want. So BAE right now. And then if we move it to exponential, it becomes 2 to the x power equals 32. Now we have to use our 5-1 knowledge. We have to do the change of base. So I need to change 32 so it has a base of 2. I know that 2 to the 5th power gives me 32. Now that they both have the same base, I can get rid of the 2's, and my final answer is x equals 5. We can try the next one. Change it to exponential. So 4 to the x power equals 2. I need to change the 4 so it has a base of 2. I can change the 4 into 2 squared. The x is still there. Remember, power to a power, and this 2, I can know that there's a little assumed 1 there. So then, now that I have the bases the same, get rid of the 2's, and now I have to multiply this power to the power, and it ends up being 2x equals 1, divide by 2, and x equals 1/2. And if you think about it, if you went ahead and you went and plugged in the 1/2 into 4 to the x equals 2, 4 to the 1/2 power is really the square root of 4, and the square root of 4 is 2, and it checks. Try the next one. The next one's actually that property. So again, if we turn it into exponential, 3 to the x power equals 1. You should recognize that anything to the 0 power will give us an answer of 1. So 3 to the 0 power equals 1. This is the property that we just saw on the previous slide. It was the very first property. This was property number 1. Try the next one. Again, let me put it in exponential form. So 10 is the base, x is the exponent, equals 1 over 100. I need to change them so that they both have the same base. I'm actually gonna change the 1 over 100. I could actually turn this 1 over 10 squared, and then I can go ahead and make it 10 to the negative 2 power. And then again, the bases are the same. Get rid of the 10s, and x equals negative 2. Next one, here's that property again, property number 1. So if I turn it into exponential, 6 to the x power equals 1. As soon as you see it's in exponential form and you see it equals 1, you should already know that that power on that x is going to be 0. Now you might sometimes see it, they might just ask you, find the value of log base 6 of 1. If it helps you to rewrite it with equals x, you can go ahead and do that. You can add equals x. So in the homework, they might just give you the problem, this problem here, written without equals x. You can add in the equals x. If the x is in the front, you can move it to the back. Okay, so like for example, if the problem was written like this, and you're used to doing the bay trick, you can move this equals x to the back and put it this way, and then you can do your bay. Let's try number 12. So again, let's move it to exponential. 5 to the x power equals 1 over 125. Again, I need to make it have the same base. So this is actually 1 over 5 to the third. And again, I'm going to just change it to 5 to the negative 3. And then now my bases are the same. Get rid of the 5s. And x equals negative 3. Next one. Again, don't know how to do this without a calculator, so I have to turn it to exponential. So 7 to the x power equals 343. I need to change 343 so it has a base of 7. And I know that 7 times 7 is 49. Times 7 again would be 343. So I'm going to change 343 into 7 to the third. It has the same base now, so x equals 3. Now, this time, notice x is the base. It's not going to be the exponent. So, again, bay trick, if you're going to do BAE, it's going to be x to the third is equal to 8 over 27. So this is stuff like we did at the beginning of the school year. So when you're looking for the base, all we need to do to undo that third power or that cube is to square root both sides. So or cube root in this case. So I have to find the cube root of both sides. And this gives me x. And again, what I can do here is find the cube root of 8 and then find the cube root of 27 individually. And this is 2/3. Remember, when it's an odd root, there's only one answer. If this were a square root that we were taking, then there would be 2 answers, like in the next problem. So again, this time, the x is not the base, and x is not the exponent. So it's going to be the answer, again, if you're doing the bay trick. So this one, we're just evaluating this power. So we're solving for x. So what we're going to do is remember the denominator. The denominator, remember, of the rational exponent is the root, and the numerator would be the exponent. So what we're doing here is the square root of 4, and then we're going to raise it to the 5th power. So this is actually going to give me plus and minus 2, and then I have to raise it to the 5th power. So this will give me positive and negative 32. Now, because we can't take the log of a negative number So you see this x here? This x cannot be negative. So in this case, we're not going to keep the negative answer. The only answer to this problem is going to be x equals positive 32. So you cannot take the log of a negative number. Remember, the answer to a log problem can be negative, but the base cannot be negative, and the number you're taking the log of cannot be negative. Let's try the next one. So I'm doing 49 to the x power equals the cube root of 7. I'm going to go ahead. I need to make them have the same base. So I'm going to change 49 into 7 squared. I'm going to change the cube root of 7 and change this to 7 to the 1/3 power. Now that I have the bases the same, I can get rid of the 7 and then power to the power 2x is equal to... We need to solve for x. So you can do this two ways. You can either know that you're dividing both sides by 2. So what we're doing is 1/3. We're dividing 1/3 by 2 over 1. Keep, change, flip. So the answer here for x is 1/6. Now, if you prefer, whenever you see this, you can also think I'm multiplying both sides by the reciprocal. So you could have multiplied both sides by 1/2. And then that would have canceled that, and you can get the same answer either way. Whatever you're familiar with doing when you have integer x equals a fraction, you're just solving for it. Let's try the next one, number 17. So again, let's turn it into exponential. We can't do this. So 5 raised to the x power is equal to 1 over 625. I'm going to change the 1 over 625 into 5 to the 4th, because I know that 5 times 5, 25, times 5 again, 125, and then times 5 one more time is the 625. So then I can change it to 5 to the negative 4. My bases are the same, and x equals negative 1/4. Then the next one. And again, remember, whenever you have the answer and it's listed as a fraction or a decimal, the answer in the exponential, that should be a clue that your exponent is going to be a negative number. So look for these little clues. So then the next one, again, let's turn it into exponential. So 10 to the x power equals 0.001. And if you prefer to go ahead and change this to a fraction, you can. Or just realize that this is 10 to the negative 3. So you can either change it so it's the same base. Oops, that should be an x. So 0.001 is 10 to the negative 3. If you would have preferred to make this 1 over 1,000 and then convert it to 10 to the negative 3, you can. My bases are the same, and x equals negative 3. So again, whenever your answer in the exponential form is going to be a fraction or a decimal, know that that exponent is going to be a negative number. All right, so for number 19, same thing. Now, notice this time they have x equals in the front. So if you prefer to put the equals x in the back, you can. So this is going to be base is 8 to the x power is equal to the 4th root of 8. Again, I need to make the bases the same. So I'm going to change this to 8 to the 1/4. And now the bases are the same. Get rid of the 8's, and x equals 1/4. Now, if you were given something like this, let's say this problem looked like log 8, and then it had 8 to the 1/4 power equals x. Again, that property, if you recognize that the base of the log and the base of this exponent are the same, this cancels out, and then you're just left with x equals 1/4. So another thing to recognize. All right, so then number 20. This is actually an exponential form. So again, if we want to put the x at the back, this is the base, this is the exponent, this is the answer. So in this form, in exponential form, we don't know how to do this. Now we could do this. What you could do is if you recognize that this base, let me write it up here, x equals, so again, whenever the base of the exponent and the base of the log are the same, this cancels, and you're going to be left with x equals 8. Now, if we had converted this to log, we would do log base 3, and then the answer equals the exponent. We're spelling bay now. So this is the base, the answer, and this was the exponent. Notice we have the same base here. It's log base 3, and then it goes to x equals 8. So this problem could have been solved either way. But look for clues like this. So when the exponent base is the same as the base of the log you're finding, that'll cancel out. Let's try number 21. Same thing. So again, if you recognize that this base and this base were the same, it'll go right to x equals 9. If not, we can also turn this into log form. So again, this is the base of the exponent. This is the exponent here, and this is the answer. So if we do log base 2 of x equals log base 2 of 9, notice the log base 2's cancel, and same answer, x equals 9. So if you see number 22. So let's go ahead and convert this to exponential. This will turn into x to the negative 2 equals 25. Now, here I can't do a change of base, but what I could do is turn this into a proportion. So what I could do is turn this into 1 over x squared, and then 25 over 1, and then cross multiply. I would get 25 times x squared, I'm multiplying diagonally, equals 1, and then divide by 25. X squared is equal to 1 over 25. I need to square root both sides. So x is equal to, and this should be plus and minus 1/5. However, this base over here, this x cannot be negative, so I only keep the positive. Now, the other way you could do it up here at the top is you could start guessing and testing, but it's easier to just solve it as a proportion. And then number 23, again, I'm going to turn it into exponential. So it's just going to be 4 to the 3rd equals x. This one I'm just evaluating 4 to the 3rd, and that's 64. And then the last one on this slide, and then I'm going to talk about one of the homework problems. So again, if it's better for you to move the x to the back, so we would be doing 4 to the x is equal to the cube root of 16. I'm going to change the base. So I could change the 16 and to be 4 squared, and then change that root and make it 1/3. And now power to the power, you'll multiply this, and you get x equals 2/3. Now, in the homework, you're going to get questions like, it's going to say, evaluate the log or logarithmic function. And let's say they give you f of x is equal to log base 2 of x. And they want you to evaluate it when x equals 16. Remember, f of x is just a fancy way of saying y equals. So really what this is saying is y equals, and then what they want you to do is replace x with the 16. And if we want to move the y to the back, so then do log base 2 of 16 equals y. And now what you can do is put it into exponential. 2 to the y equals 16. 16, to change it to a base of 2, would become 2 to the 4th. Get rid of the base 2's now, and y equals 4. So when they give you problems and they're telling you what to plug in for x, you can just go ahead and plug that in. And if you want to move that f of x, change it to a y, and then put it in the back, then just use your Bay trick. Now, when we do start using the calculators, the log button on your calculator, you're going to find a button on your calculator that has the letters LOG. That button is evaluating things with a base 10. Coming up when we start doing calculator questions, we're going to learn how to do the change of base. If you have an older calculator, if you have the newer calculator, there's actually a function that will change the base for you. So, for example, if this were a question, we could go ahead and do this on our calculator without having to convert it to exponential. But that'll be coming up later on. All of the questions on the test will be able to be converted to exponential, and you will not need a calculator. This little base here, if it doesn't have a number, it's assumed to be a 10. So if you get a question where it has f of x equals log of x, and they say let x equal 1,000, what you're going to do is you're going to take the 1,000, you're going to put it here, and then we could also take this f of x and put it over here. So really what we could do is do log, and remember what's assumed here is a little 10, and then we'll put the 1,000, and then it equals y. So then we're going to do 10, and then if we do our Bay trick, B-A-E, so 10 to the y power equals 1,000, and now we have to change the 1,000. This will become 10 to the third. Get rid of the base 10s, and y equals 3. So if they just give you a question like this with no little base there, you assume that there's a 10 there.